Let me first thank you for coming for this talk. And let's start with introducing myself. So my name is Anna.
Take the mic closer.
Is it better? Okay, great. Yeah, sorry for that. So yeah, I'm going to try and introduce myself. So my name is Anna. I'm based here in Prague. I work at Sentinel One as a senior software engineer. I mainly work as a backend developer or SaaS developer in Python and Go. And today I would like to talk with you about uh, a particular use case that actually happened here at Sentinel One. So first, our agenda is going to be me describing what is a ClickHouse for those of you who haven't stumbled upon this service yet. We're going to talk about its pros and cons. We're also going to talk about different use cases. Then we're going to talk about choosing an appropriate Golang library if you would like to use this database for one of your services. And then we'll, of course, have some space for questions and answers. So as I was talking about a particular use case that actually happened here at Sentinel One, one time I was approached with the task to develop a service that needed to stream analytical data. So the data source in my particular case was several Kafka topics, where each topic had a huge amount of data. Each message represented a change in a relational database. So as you can, and also there were multiple producers of the data that sent the data to the Kafka topics. So as you can imagine, we were dealing with lots and lots of data. Every topic could have had up to like hundreds of thousands or even millions messages. And we needed to write a service in Golang because this was the company policy to write a service in Golang. The producer was sending data asynchronously because, as I mentioned, the message in the Kafka represented a change in the database, which can, of course, happen at any time. So data was being produced asynchronously. So we needed persistent storage because the service was supposed to periodically take samples of the data, do some calculations and aggregations of the data, and report it to another service. So let's leave it at that, and then we could talk about why this use case is a good example why we want to use ClickHouse as persistent storage. So what is ClickHouse in the first place? So ClickHouse is a database. It's a time series based database. So as for the features of it, first of all, it's open source, which is one of the best things that I like about it. Code is freely available to you. You can also not only view the code, but also contribute to it. And of course, we like things open source. Another good feature of it is that ClickHouse uses columnar storage, which helps you reduce the costs of disk space. And it's also really scalable, so you can use multiple nodes within one deployment. It scales really good horizontally, which is also really good for services that have to deal with a huge amount of data. As for pros and cons, so let's start with pros. The first one is really fast reads. So this is what ClickHouse was designed for running on large databases with minimal latency on read queries. Another, I briefly mentioned that ClickHouse is highly scalable. It scales really great horizontally across nodes. So if you need it for a high throughput application, it would be a great choice. And also already briefly mentioned storage cost efficiently. Due to the columnar nature of the storage, it helps you save on the disk space, reduce the cost of the storage, which is going to save you or your company a lot of money if you're dealing with a huge amount of data. As for the pros, so as I mentioned, ClickHouse was designed for really efficient reads and not so much for writes. So if your service is expected to have a lot of heavy writes, maybe ClickHouse would not be a great choice. There are early non-optimization for write queries. Also, complexity is another thing because it's not your classical relational database. And if you also would like to use to go more into in depth of like more advanced features of ClickHouse, it might be a little bit complex. Of course, there is documentation, but you still have to spend quite some time figuring out how the advanced features work. And another thing which is kind of manageable is the lack of integrations. So if you compare ClickHouse with your classical relational databases such as MySQL or Postgres, of course you would have much fewer libraries and integration tools available for ClickHouse because it's not so widespread. As for the use cases, so I would say that main use cases at which you would want to look at ClickHouse as your persistent storage is real-time data analytics, because if your service involves any queries that are querying a large amount of data, such as, for example, event data or user actions or server logs, then ClickHouse would be a great choice. Also, time series data, because it's commonly used in monitoring, observability, due to the high ingestion speed and query efficiency. And this is what ClickHouse was originally designed for. And another use case is advertisement tech and market analytics. Because this is an area where a lot of large data set processing is usually involved into. So if you're developing a service in this area, I think ClickHouse would also be an optimal choice for you. I didn't want to talk too much about the use case that we had at Sentinel-1 here, for obvious reasons. So let's take as an example an imaginary use case. Imagine that you are running an e-commerce website, so an e-shop where there are different items listed, and you want to implement two features that you can commonly see in popular e-commerce websites. So the first one is to show the most popular or most frequently bought item on your website. And another one is that for a given item, if a user presses on an item, they would be able to see how many users are currently viewing the item. So for this purpose, it would be a ClickHouse as in our database. Let's say we create a table. And if you look at this table, what we have here is that we have user ID, which let's say is going to correspond to the primary key of an item that we have somewhere else. It could clearly be like a classical relational database, such as, for example, MySQL or Postgres. Then we're going to have the item ID, which is going to correspond to the primary key of some sort of an items table. It's going to reference a particular item. Here we're going to have action column, which is going to contain a string. So view is going to represent an event of user with this ID, viewing item with this ID. We can log such an event when, for example, user opens an detailed page for an item. And we're going to have a buy action. Of course, depends on the implementation of your e-commerce website, but we can log such an action as, for example, if a user clicks purchase button on your website. And of course, we're going to have timestamps that represent at what time did the action happen. So now to the specifically goal related part of this talk. So what library are we going to choose if now you've already decided that using a ClickHouse database would be a great idea for your application? So for my research, I found two libraries that are most actively developed at the moment. there were other options, but either they were not maintained anymore, or the community wasn't as active, or there weren't enough features available. So I can recommend one of those two. So the first one is the ClickHouse Go library. It's an official Go client. It's developed and maintained by ClickHouse developers. So what is it good for is that it provides low-level control. So if you need to use any advanced features of ClickHouse, this is the way to go. Another good thing about this library is that it supports native protocol, so it's going to increase performance significantly. And also it has advanced ClickHouse features, so again, if you do need them, other libraries do not offer that. You would have to go a mile to implement it yourself. There are available APIs in ClickHouse Go library that you can just use. However, like the downside of it is that it's going to be a little more complex, and it will probably require you to write slightly more code, and maybe wouldn't be as readable as with the other library that I've looked into. So this is an example of using a ClickHouse Go. So here in this code, I think it's pretty straightforward. We're using SQL Open to connect to this database. This is the connection string that we're going to use. Of course, you don't have to use TCP. It can be any protocol. There are a variety of options available. Then you specify the host, the port. So the port 9000 is a standard port that ClickHouse run on. Of course, it's also configurable because there are applications that also run on port 9000, or maybe you would like to run several ClickHouse instances on a single node for any reason. This is configurable. Then we're checking if there was any error while connecting to the database. If not, then we're returning a connection object, which is going to represent a connection to the SQL database, and we return no error. As for the second option that I mentioned, it's a Go ClickHouse library developed by Uptrace community. Generally, Uptrace provides different tools for observability monitoring, and they also have an option for integrating with ClickHouse because, as I mentioned, ClickHouse is often used in observability monitoring solutions. So what is Uptrace good at is that it provides higher level abstraction than ClickHouse Go. So it even kind of simulates ORM if you would like to use it in your code, if this is something that you're used for. Also, it's more focused for tracing and observability. So if this is your use case, you're developing a service for tracing and observability, I think Uptrace could be a better option. The downside of it would be that it doesn't have as many advanced features as ClickHouse Go does, and it's not so low level, so it might have worse performance. So add a particular use case that I had at Sentinel-1, in the end we decided to use both of the libraries, and we decided to use ClickHouse Go for querying the actual data. And we decided to use Uptrace for migrations, because in migrations you don't really need the performance, but you would like to have your migration files be readable and easily modifiable by other developers. But with our queries that actually produce the data, we wanted to opt for the better performance. So we went for ClickHouse Go for them and Uptrace for running migrations. This is an example. So what we're doing here is pretty similar, as you can see, to the ClickHouse Go. However, it's a little bit prettier, I would say. So you're connecting just using one line. Again, as you can see here, it uses another protocol to connect. And the return value is going to represent some sort of a client that has different methods available. So here you have an example of executing a select. And this is what I said is kind of mimicking the ORM approach, is that I can define a structure. It's going to represent some sort of an entity, which here, let's say that it's just going to have one parameter. I'm just going to fetch count on some number of rows. And I can select the data and immediately write it or like load it into my structure that I've defined here. Here I'm using a query. So basically, if I wanted not to execute a count, but let's say select results on a column, I would just use the column name here, but it's yeah, sorry.
Can I have a question like from where you are selecting the count from?
So here it's sort of just like it's as if like in Postgres you would do just select count. So
I think we should leave question to the end.
Okay, sorry.
yeah, but the answer is pretty simple. It's just an example. So here it's not that it has any like in-depth meaning. Yeah, and also we're using a context here. By the way, ClickHouse Go also supports using context. It just requires a little more configuration and a little bigger number of steps. Here it's as simple as just like using a context here and scanning it into the context. Okay, so if I go back to our example of the e-commerce website, the first feature that we wanted to develop was to display the most popular or the most bought item at a point in time. So let's say we're going to refresh our most popular item every 5 minutes. Of course, depending on the size of your e-commerce website or the scalability or your use cases, you can choose any other interval. But let's say we don't want to refresh the item every second, but also refreshing it like every hour is going to be too late. So let's choose an interval every 5 minutes. And this is going to be the query that we will run on our statistics table that I previously showed to you. So we're going to count the number of events of buying an item, and we're going to group it by item ID. So we're going to count the number of buys for every item that has happened in the last 5 minutes, and then we're going to order it by the number in the descending order, and then we're going to have the top one, which is going to give us an item that was bought the most times during the last 5 minutes. We're executing this query, and we're going to, by the way, this is using the ClickHouse Go library. It's not visible here because it didn't fit into the slide. So we're executing it, and we are storing our results into an int64 variable, because item ID is a primary key. Let's assume it's int64. We're checking if it was successful, and then we're returning item ID. On failed, we're returning -1. As for the second use case, counting how many users are currently viewing a particular item. Again, let's assume that we're going to refresh our data every minute. Again, because I think if we do it like every second, imagine a user opens a page with an item and the number just keeps changing and changing and changing. If we have too big of an e-shop, if we have too small of an e-shop, then it's not really worth it to refresh it like every second. So let's choose an interval 1 minute. And if we look at our query, by the way, you can see queries look pretty familiar, right? We're just using normal SQL. So I think it's another advantage of using ClickHouse. Here we're going to count the number of events where the action was viewed for a particular item ID that we take as a parameter. And we're going to limit it for events that happened during the previous minute. And we're going to load our result into the viewer's count variable. Again, checking for the error. If there was some error happening, we're going to return -1 and an error. If not, we're going to return the count that we retrieved from the ClickHouse table. So that's more or less it for me. Now we have space for questions.
All right, so I wanted to ask, in a local host, did you prepare some kind of Dockerized environment, and if ClickHouse actually provides some kind of Docker image, and if it's easy to use or?
Yeah, they have an official image. So when, like for the purposes of the local development, I did use the Docker images provided by the ClickHouse community. In production, we had a dedicated cluster with ClickHouse, but of course you can also use it in production because the settings for the ClickHouse also allow you to have like a setup for production, a setup for development. So I think if it's a smaller service, just using Docker in an EC2 would be more than enough. In our case, we opted out for a separate cluster.
I would have a question about like this.
Maybe, if I may, because it's hardly heard in the back.
Okay, so I have a question like whenever you have as well like the definition of the table, because like this is something which might be interesting, like to visualize partitioning strategy or like how the data are physically stored in some way, so it can kind of perform. The query looks like a Postgres query or any query, but like how the data are physically stored on the server, so it can like query faster. Like what's the magic, right?
Okay, so unfortunately, I don't have like a visual example of that. So if you're interested in how the definition of table looks, it actually looks pretty similar to a definition you would have for MySQL or Postgres. It's just create table. The differences are really small. ClickHouse offers you some data types that are not available in your classical relational database, but I guess that's pretty much it. As to how it happens on the lower level, so as I mentioned here, the storage is columnar. So it's faster because let's say you have like in this example, for example, we are counting just per item ID, so we have to query only one column. ClickHouse doesn't have to load. Imagine if it was like a stored per row. In order for you to find the value of a particular column, it first has to find a respective row and then extract the data from the row. In ClickHouse, because it's stored per column, if you know or ClickHouse knows what column to query, it does not read from other columns. So this is why it's faster. Also, what makes it faster is that if, for example, you're using it for some time series data, like for example, observability, let's say you're storing logs, and you're interested in log data, you can actually set it up in your ClickHouse deployment that your data, which is like old enough for you, it gets aggregated automatically. Unfortunately, I can't answer exactly how is it being done because I'm not a ClickHouse developer. But what I've seen using ClickHouse is that the data is actually being aggregated. So if let's say for the same ID, you have different results, you can specify it in the definition of the ClickHouse table that you want to aggregate, let's say you're interested in average, right? So you have 3 rows for the same ID with 3 different values. It's going to be combined into a singular row with the average value, which by the way also decreases disk space and makes it faster because you have less rows.
Thank you. Any other questions in the audience? Okay. Yeah, okay, go question.
Hi there. One of the ex-ClickHouse developers here. I did minor contributions, and I wanted to share some of the slides with the person who developed ClickHouse in the first place. And he got a question about the cons slide. And I quote, like, compare it to what are those cons?
So if we are talking about especially writes, so I would say compare it to, I'm not comparing it to other time series based databases. It's more of a comparison to a classical relational database. If we take Postgres or MySQL, it wasn't designed specifically for reading or for something else. It's more of a broader use case. So you have optimization for writes in Postgres. Maybe I'm not aware, but I haven't seen any write optimization for ClickHouse. As for complexity and the lack of integrations, I think it's also it's coming from a place where people are mostly used to classical relational databases. So if you are going to look up the number of different libraries for working with Postgres in your Golang application, you're going to find tons. When I was looking into libraries for working with ClickHouse, I found like 2.5.
Okay. Let's maybe chat later. He dropped some numbers though about the writes, like they support writes of 500 million rows per second and 300 gigabits per second. But let's let's discuss this.
Thanks a lot. We had a ClickHouse developers on the line, so definitely it's good to know that like Kostek can translate. Yeah.
Let's chat,
I think there was some question over there. But we're still have time? Yeah, okay, cool. Yeah. You have fun as well?
Hi. I have two questions. First, do you have success stories at Sentinel-1 of migrating to ClickHouse?
Yeah, so I learned about ClickHouse when basically we had this use case, as I mentioned. We have a Kafka topic that consumes from multiple sources, has lots of messages, really active, and we wanted to read from this topic every 5 minutes. Then if you can imagine, like every read would be like a snapshot of a state of our system, of data in our system. Then we needed to execute an aggregation, like calculation and aggregation on top of the calculation. And in the end, you end up with like a single number. And this number has to be reported to a consumer service, also every 5 minutes. So originally we thought about what if we just execute this aggregation and calculations on, let's say, Postgres databases, which are acting as producers for Kafka topic. But imagine if you had to execute it every 5 minutes on a Postgres database with tons and tons of data, and on top of that, you have multiple such databases, and then you have to write all of this data to this consumer service. It's not really like we wouldn't, I haven't tried it, but according to my calculations, it would cause significant performance issues. So this was the source of an idea for using ClickHouse. In this particular case, I think if we go back to my use cases slides, I would say that it's a great example of ad tech and marketing, because this data, it wasn't used specifically for marketing, it was used mostly for finance purposes. And also you could, it also kind of implies a use case of using a high load system, because if it's every 5 minutes on a huge amount of data, it generates a pretty high load. So yeah, if it answers your first question.
Yeah, can you tell us some numbers? You mentioned that it's more efficient in storing data, and I suppose you saved a lot of storage and maybe CPU.
So I'm not sure if I can give you like any like real data, but I can give you an approximation. So let's say that we have actually we have more than that, but just so that it's easier to calculate. Let's say we have 100 Postgres databases, so producers of the data. Every database, as it's relational, we're actually consuming only one table, but the table is pretty huge. So one table can take up to 1 terabyte of size. However, I haven't seen on any of the deployments of the ClickHouse the whole database being bigger than like a couple of gigabytes. And this is even including the fact that a single ClickHouse database consumes from multiple Postgres databases.
Thank you. And if I may, last one question. You mentioned that you use library for migrations. Do you apply migrations on your own on such a big large table. Just run code and that's all.
Okay, so it's a really complicated topic. I don't think that we have more minutes, but it took me quite some time to figure out how to apply migration in this particular case.
Okay, thank you, Anna. There are some questions in Slido, and I know Slido wanted to. Okay, so there was a question about does ClickHouse support transactions?
Unfortunately, at least with the engine that I used, well, I think ClickHouse itself, it does support it, but ClickHouse Go library, I haven't found any possibility to run it in a transaction. So basically, when I ran my query using ClickHouse Go, I ended up with an error that cannot run in the transaction. But I think it's not ClickHouse's fault, it's more of library's fault. Maybe it is configurable somehow. I'm pretty sure it's configurable somehow.
Okay, thank you. I think that this was partially mentioned, like what you use for your projects or product, like what you use ClickHouse for your projects or products, and the scale kind of as well. And then that's just a comment. So I think any last question, one question from the audience? Yeah. Okay. So thank you so much, in that case, Anna. I believe that Anna will be around